Okay, now, if we know a vector function, the question is, how do we find its potential function, or even if one exists? Okay? And this isn't really too bad of a process. So we actually start here by figuring out, well, by saying, by starting with a potential function. Then we do its gradient, and that's a very straightforward calculation, so that we're going to let our vector function be what we get when we take the gradient of this potential function. Okay? So this function is gradient of this function. Now, if we didn't already know what this function was, if all this information is missing, or at least this information, if we erase our knowledge of this function, so we go, okay, we don't know this function. This is exactly what I'll do if I make up a problem for the test. I'll start with a potential function, find its gradient, and then ask you to figure out what the potential function was. Okay? And I might well ask you also to figure out if there is a potential function. Is it possible that this thing is conservative? By the same process, you'd be able to figure out the answer to either question, or both. Okay, so how do we figure it out? Well, whatever we've got times I is our partial of our potential function, whatever it was. We can't see it anymore because I crossed it out, right? Okay, potential function isn't there, but whatever it was, we know that this has to be its partial derivative with respect to x, because of course the gradient is the partial with respect to x times I plus the partial with respect to y times j. Okay, so this has to be our fx, and this has to be our fy. And I don't think I ever, yeah, okay. This is our xy, okay, our fy. Okay, well, starting with the fx, what can we conclude if this is the x derivative of a function? Okay, well, if it's the x derivative of the function, then it's an antiderivative of the function with respect to x. Now, antiderivative of 4xy cubed with respect to x, the 4y cubed is just a constant. You bring that out of the integral, you're going to get an x squared over 2 plus a constant. Okay? So your antiderivative is going to be 2x squared y cubed, and this should be very obvious, plus a constant. Now, my constant I wrote as a function of y. Why is this? Because when we're taking a derivative with respect to x, any function of y acts as a constant, so our integration constant will be a function of y. Okay? And if we were doing a function of, with an I, a j, and a k component, we could do the same thing. Our integration constant, when we integrate with respect to x, would then be a function of y and z, since we're in a context where our functions have dependence on two other variables. Okay? So anyhow, this is what we do. There's our antiderivative plus a constant, and our constant is a function of y, and this is constant with respect to x. Okay, well, then we say, well, okay, then our 6x squared y cubed plus 3 is our fy. So what is our f function? Well, it's going to be an antiderivative of this with respect to y. Okay, our general antiderivative, you can check this out, our antiderivative of y cubed is y to the 4th over 4. What am I missing here? This is y squared, okay? Okay, and I think there's probably a continuing error in here, so let's fix it. No, it's all right. Antiderivative of this then is 2x squared y squared. And then antiderivative of 3 is 3y. And then we have our integration constant. With respect to y, h of x is constant. So that's our most general possible integration constant. Okay, now we reconcile these two functions. The function we have here agrees with this part of our function that we have here, okay? In other words, our f function is this, and our f function is this. Can they be reconciled? Well, certainly we have the same quantity here as we have here. We have a g of y here, so we can handle the 3y. And we don't have any other x dependence in either function, so our h of x is going to end up being 0. Now let's write that out a little more formally. We say f of xy then has to equal this, but it also has to equal this. What's our conclusion? Well, our conclusion is that g of xy is 3y plus c. Okay? In other words, the g of y function we have over here would be 3y plus some constant. And our h of x function is just equal to that constant, so that f of xy is this. Okay? It's got our 2x squared y cubed, it's got our 3y, and it's got our c. Now it's a little vague about this c here, so I'm going to let you kind of puzzle that out, but remember that clearly if this whole thing without the c is an antiderivative, then c is, if you add c, that doesn't change the fact. I also made an incorrect statement. I said our h of x is 0. Our h of x could be any constant. Okay? So, that's the general procedure. Again, we simply set our fx equal to what fx is and integrate with respect to x. And we set our fy equal to fy. And I swear I write it down and can't find it. Our fy. And then we integrate that with respect to y. Keeping in mind that when we integrate with respect to x, our integration constant is a function of y. And when we integrate with respect to y, any function of just x is going to be constant with respect to that integration.